When we talk about effective ID, what we're really talking about is what's the smallest point from the hemostasis valve all the way to the distal tip of the guide catheter. And in most guide extension catheters, the smallest area is in the guide catheter with the push rod. So when we were looking at the GuideLiner catheter, we decided we wanted to use a rectangular shaped ribbon wire.
What that gets us is additional space within the guide catheter to deliver interventional devices. It allows you to deliver more gear, larger gear, through your guide catheter, through the guide extension, and to the target lesion.
We're 56 thousandths from the moment you enter the guide catheter to the moment you exit the distal tip. When you look at some of our competitors, they chose to do a round push rod. They're giving up, 5 to 6 thousandths in that guide catheter. The design differences can seem small. In the end, that makes a huge difference on whether or not your case is successful. 5 or 6 thousandths in effective ID, that's a big number. If you look at metal support options for catheters, you're kind of left with two viable options, and that's realistically a coil reinforced design or a braid reinforced design. We decided for the GuideLiner that the choice was obvious to go with a coil.
We came to the conclusion right away that a braided design does not hold its shape very well. In our bench testing, around a 7.5 millimeter bend, a braided guide extension catheter construction will give up 10% of its diameter versus the coiled guide extension catheter does not give up any of its diameter. Our testing also found that the stiffer distal shaft of a competitive coiled guide extension catheter will give up 7% of its diameter versus the GuideLiner V3 catheter's coiled distal shaft, which does not give up any of its diameter.